Thank you, and welcome to my talk. I'm going to show you two patents, but first a presentation about the institute I come from. I'm Álvaro Peña, and I come from Instituto de Magnetismo Aplicado, which is a research institute that belongs to the Universidad Complutense. You can find us in the stand of the Comunidad de Madrid. Of course, being a research institute, we have a strong and high-quality scientific production, but also we have a strong focus on technology transfer, with lots of patents done and a lot of collaborations between the companies, either private or public. Our research group ranks among the very best of the university and has the dimension of technological transfer. We focus mainly at magnetism for different applications, but also in material science, and as I will show you now, recently in graphene synthesis and applications. So the first patent refers to a synthesis method for... no, never mind. So the first patent, this one over here, refers to a synthesis method based on a ball milling technique, which is basically a mechanical exfoliation in which we use graphite to obtain a nanostructure graphene-like material, in this case, few-layered mesoporous graphene. This technique, its highlights are that it is low cost and it is done in a one-step process in a very fast manner. We obtain a material which is an agglomerated of a few layered graphene domains. And in this technique, we are trading, let's say, quality for quantity, meaning we are looking for a technique that it is scalable and that can fulfill industrial requirements, but we are not looking for a material that is very high quality. We have some defects, but I will show you now in a couple of applications that these defects are in fact what we are looking for. So the first application is microwave absorbance. So we made a composite material using this few-layered mesoporous graphene and magnetic microwires that it is applied like if it was a paint. It is a paint-like composite. This should be a video, but it is not running. I don't know, Mr. Chair? But nevertheless. So basically, we make a composite material, and we test it by focusing an electromagnetic wave in the microwave frequency to it. Normally, a material will reflect all of the intensity. So you will have full reflectancy is what happens normally with a plane, let's say. But at some frequencies, our material, due to its high specific surface and the presence of defects, absorb that wave. Meaning, when it reaches that frequency range, that in our case is located in the microwave range, the signal is dissipated into the material as thermal dissipation. So you will see here, these are the spectra. We can take sweeping the frequency, and in this axis here, we have the intensity of the reflected wave. So a reflection of 30 dBs or below means that 99.9% of the incident wave is being absorbed in the material. This has a huge interest for radar cross-section reduction, or even for electromagnetic interference shielding in sensible electronic components. The next application, let's hope this moves, okay, refers to a sensor to detect nitrogen dioxide in air, meaning a gas sensor. This gas sensing, we monitor the presence of nitrogen dioxide as a change in the resistance of the material. But some other components, as ammonia or water, can interfere this measure. So we need to build a device that is highly selective to N02 and not to these other two components. We have done that, and we have obtained a material from this few-layered mesoporous graphene that has a high response to nitrogen dioxide, even in relative high humidity environments. And the limit of detection of this, the limit of nitrogen dioxide detection of this device sits around 25 parts per billion, which locates it well below the recommended exposure limits. And the highlight of this work is that we can get this material that we have made in a very simple manner and just deposit it over some electrodes, and then we will have our sensor. You can find more details of this either on the patent or in the recently published article, or you can come to the stand of Universidad Complutense and ask us. Thank you very much.